So now, for a perspective from Congress on some of our key climate and technology innovation questions of the day, it's my pleasure to welcome Representative Sean Casten from Illinois' 6th Congressional District on the northwest side of Chicagoland. Congressman, welcome back. How are you today?
Good. Thanks so much for having me. I really appreciate it.
It's great. So just a little bit of a warm up for our audience here, Congressman. The Congressman serves on the House Science, Space, and Technology Committee, which oversees NIST and NASA, among other key agencies. He serves on the Select Committee on Climate Crisis. He also serves as co-chair of the New Democrats Climate Change Task Force, and he has dedicated much of his professional career to fighting climate change. Outside of the science and climate change, the Congressman is also the vice chair of the House Financial Services Subcommittee on Investor Protection, Entrepreneurship, and Capital Markets. Perhaps most notably, Representative Casten is one of about a dozen trained engineers in Congress, with a Master's of Engineering Management and a Master's of Science and Biochemical Engineering from the Thayer School of Engineering at Dartmouth College. He co-founded a company called Recycle Energy Development, the acronym being RED, which focuses on recycling waste energy and converting energy facilities to cleaner, more economic uses. Congressman, you and I have had the opportunity to chat quietly about this. I want to thank you again for joining us. We look forward to hearing your perspective on the bipartisan innovation legislation currently being negotiated in Congress, as well as the prospect for action on climate change and other key technology issues. Welcome again, sir. The floor is yours.
Thank you. Well, it's a pleasure to be here. It is a good time to be an engineer, mechanical or biochemical or something in between. And I say that because, you know, the laws of the United States are very much in flux when it comes to climate. They are not moving anywhere near fast enough. But the laws of physics and the laws of economics are kind of immutable, and we're catching up to them. And that's creating a reality both in terms of what we have to do legislatively and what's happening in the private sector. As I've said to some of my colleagues, you know, sometimes leadership is hard, but we can still follow. And when we're seeing a lot of movement in the private sector, and I want to sort of give a little bit of the lay of the land. By quick bio of how I got here, I was 16 years in the clean energy industry, worked with just about every industry you can think of, from paper mills to steel mills, hospitals, universities, going and taking over their energy islands. And I don't like the word energy efficiency, making them more energy productive, because that's really the opportunity we have in our economy. We for years have embraced labor productivity as the route to growth. How do we get more out of fewer units of labor? And we've been much lazier about our energy productivity in the United States. Give you just a number to think about. We have a $20 trillion economy that uses 100 quadrillion BTUs of energy a year. That means that for every 1,000 BTUs we consume, I love speaking to you guys because I can use words like BTU, and you know what I'm talking about. For every 1,000 BTUs we consume, we create 20 cents of economic activity in the United States. The United Kingdom generates 38 cents for every 1,000. Switzerland generates 60 cents. That's what I'm talking about when I say energy productivity. We in the United States do a very bad job of turning primary energy into dollars. And that's both depressing, but also an enormous opportunity. And when I say these laws are catching up, that's what I'm talking about. Because all those projects that I did in my past life, we never used super advanced technologies. We just used existing technologies more productively. What we have to do from the physics perspective, that everybody who's in this line of work we're in knows, is we basically have to decarbonize our economy in 15 to 20 years. We're out of time. In order to do that, we need to massively electrify our loads from our transportation sector to our industrial sectors. Realistically, that means building at least 1,000 gigawatts of new generation in the next decade. By the way, that's as much as we already have. So that's doubling the entire capacity of the US fleet, but building clean generation this time. And then building several $100 billion of additional transmission, because we are building new generation where the resources are, the wind, the solar, the geothermal, the biomass, the nuclear, and building new loads where the loads are. Maybe it's the electric vehicle chargers along the highways. We're gonna need a lot of wires for that. Now, that sounds hugely daunting. And if I said to you, our challenge, in this Congress, in this moment of partisanship and discord, is to figure out how to deploy that kind of capital in 10 years, you might say that's just not realistic. But keep in mind that when we passed the Federal Power Act in the 1930s, we electrified rural America in a decade. Keep in mind that when we deregulated the power industry, the 1992 Energy Policy Act, we built 200 megawatts, so a fifth of what we need to build, but we built 200 megawatts of primarily combined cycle in 10 years. And we, in the former case, was primarily at the direction of the federal government. We, in the latter case, was primarily the private market reacting to changing economic systems. But we know we can do that. And we know we don't have technology constraints. Look at what Switzerland has done. Look at what the UK has done. We know we don't have talent constraints. Let's not be constrained by our ambition, right? Because that's really the only thing holding us back. For us to do that, we've also got to build a whole lot of energy storage, because the way to modulate load, we've seen already in some areas in the Midwest where the ramp of intermittent renewables is actually leading to an increase in CO2 emissions, because we're running a lot of gas turbines at half load to modulate up and down. And so if we build out more energy storage, we can better absorb those swings and excesses, and that's going to be a key to decarbonizing. And of course, the transmission. When the Biden administration came in and put their priorities together, what they wanted to do, their American Jobs Plan was substantially informed by the work we did on the Climate Committee in the last Congress that essentially articulated a goal to get to everything I just described. The White House asked the Senate to do as much of that as they could on a bipartisan basis and the balance through reconciliation. Thus, we got to the bipartisan infrastructure bill and Build Back Better. Of course, we've only passed the first of those. Most of the climate provisions are in the Build Back Better Act, so we still have to get that done. But there's some meaningful stuff that's in the, I guess we're now calling it the IIJA, the Infrastructure and Jobs Act. And this is all rolling out right now and being aware of. The energy storage piece I mentioned, we wrote in our office with Bill Foster's office a bill to put $500 million specifically into the deployment of grid scale energy storage technologies. That RFP is now out on the street. So if you've got opportunities, where there's congested nodes, to go put that in. There's significant federal dollars to do that, and we've got a path to double that up in the next appropriation cycle. We also got a provision that we wrote in our office, the Clean Industrial Technology Act, specifically to roll out technologies in the hard to decarbonize industries. How do you think of these as the places where we use fossil fuel, not as a source of energy, but as a chemical reducing agent? How do you make fertilizer without natural gas? How do you make steel without net coke? And so we've got another $500 million in that bill that's specifically to deploy those technologies from lab scale out. So, as you go and look at that, I want to see those things deployed because it's the legislation that our office wrote, but also because it's critical. Because if you don't know how to make silicon without net coke, if you don't know how to make cement without natural gas or coal, if you don't know how to make steel, then you don't know how to make a solar panel, right? And I don't know how to have a zero carbon world without figuring out how to decarbonize those things. So we've got that's out. We've also been working, there's this really interesting dynamic going on. And this is again where the private sector, I think, is leading. If you go on, look at the stock market today, ExxonMobil is trading at about a 7 times multiple on earnings. Tesla is trading at a 70 times multiple on earnings, 70. Private capital markets are basically already saying, we know who we trust with our money to make long-term investments. We know who's building the technologies of the future. We know who's building the technologies that have fundamentally lower operating costs, and that's where the capital's flowing. That's awesome. It's fantastic. It's why we're seeing so many more jobs being created in the clean energy space. But it also means that you can see these challenges coming. And so we're working with Department of Energy and some of the appropriators to go through and figure out where is our grid going to be constrained as we add these electric loads, so that we know where the points are that we need to proactively go out and up the transformer capacity. Think about like your average gas station has a peak electric load of 100, 200 kilowatts. That's one supercharger, right? So where are we going to build out this infrastructure, and how are we going to make sure it's a construction problem, but it's a problem. We've got a whole bunch of other things that we're working on, and and you had mentioned that the bipartisan, the Competes Act is a really big thing that's coming through, and I would put that not in the clean energy space, but it's related to it in the sense that I think there's a recognition in the wake of COVID that our 30-year commitment to prioritizing declining consumer prices at the expense of all else has basically run the course. I was talking to a Bison gear manufacturing in my district last week, and I said to their CFO, "How are you thinking about inventory management after your last 2 years?" And he said, "You know, all of my grad school teachers taught me that the key to financial management was running just-in-time inventory, and now we're having to teach people to run just-in-case inventory." And so we're seeing these huge swings. And what does it mean when we know that we allowed our supply chains to become that brittle? How do we make sure that we have an insurance policy in the system? Some of that's going to mean carrying more working capital, but a lot of that's going to mean moving manufacturing facilities, moving supply chains back to the United States, so we don't depend as much on these other sources. And that's really a big, at core, that's what the Competes Act is. It's $59 billion specifically to provide the training and the resources to bring this manufacturing back to the United States. It's really important. It's really good stuff, but it's going to lead to a couple really good challenges, but challenges nonetheless. The first is that our economy for the last year and for the foreseeable future is creating jobs much faster than we're creating workers. And that's hard for employers who are struggling to find the talent. It's great for labor because you're seeing your wages go up, as you have more bargaining power. Ultimately, it means that if we don't find a way to fix our immigration system, we're not going to be able to give the private sector to do what it wants to do. Bring this manufacturing back, make our supply chains more robust, give ourselves more domestic coverage. And that's a good problem, but it's a problem we have to solve. The other challenge that it's created is that the commitment to offshoring, if you can put a plant in El Paso and pay $8 an hour, or you can put it in Ciudad Juarez and pay 80 cents an hour. All of our pressures have been go cheap, go cheap, go cheap, go cheap, get cheap stuff to the US. As we bring those jobs back, as we bring them back and stop just sort of chasing the lowest dollar, that's going to be a little bit inflationary, right? And that's the inverse of the trade, right? Because the trade we've made for 30 years is cheap goods at the expense of all else. And if in fact we're going back on that, we need to be thinking about that trade, make sure it's done in an equitable way, make sure we think about, can we structure this in a way that wages are growing faster than the cost of goods so that everybody wins? What do we do for folks who aren't working? How do we make, what happens to Social Security payments and those sorts of things? And I think these are good challenges, but they're real challenges to have. And I think it's as I said at the start, it's a great time to be an engineer because it means that we are doing this massive construction in the United States. It's going to require a lot of people to design and build things. And I want to leave you then with just the last big challenge that creates is that on any objective measure, the transition to clean energy creates way more wealth than it destroys. And I think intuitively we know that, right? Mm-hmm. If you have a solar panel on your roof, you got more dollars in your pocket because you don't pay an electric bill anymore. If you've got an electric vehicle in your driveway and a solar panel on your roof, you got even more dollars in your pocket because you don't pay for gasoline anymore. And everything that I just talked about is a transition to a new piece of capital infrastructure that's going to require people to build it, to manufacture it, to install it, to commission it. And then once that's all done, they're very operator light. And so we're creating this enormous amount of wealth in our society, but we're creating the wealth in a way that's going to create that it already is creating a huge wealth transfer from the energy producing regions of the country to the energy consuming regions of the country, and specifically to energy consumers. And I think we have a challenge that we have to think through in terms of the equities of that, of how we make sure that as we build that bigger pie, we make sure that everybody gets a slice. Because the private sector on their own will not do that. When you look at, the fact that West Virginia has the same population as Philadelphia, but only about a third of the GDP. And that's the difference between an energy producing region and an energy consuming region. And our obligation as legislators, as citizens, as just people of the planet, is to make sure that we show just as much love and respect to the West Virginians as we do to the Philadelphians, as we do to the Illinoisans, but always put a priority over the Illinoisans who are engineers, because those are the best people.
I agree. I agree.
All right. So thank you so much for giving me the chance to chat with you.
Well, thank you. It's your perspectives are spot on, Congressman. And now we're honored to be joined by Congresswoman Young Kim. Congresswoman Kim represents California's 39th district, which spans parts of Los Angeles, Orange, and San Bernardino counties. She serves on the House Committee on Small Business, the House Committee on Foreign Affairs, and most importantly for ASME, the House Committee on Science, Space, and Technology, where she sits on the Aeronautics Subcommittee. On the Small Business Committee, she serves as the ranking minority member of the Subcommittee on Innovation, Entrepreneurship, and Workforce Development. Ladies and gentlemen, I'm impressed by the fact that the House passed 3 bills co-sponsored by Representative Kim to support STEM opportunities for students and early career researchers during COVID-19. I've had the opportunity to speak with her privately earlier in the week. She's been a great supporter. She has been named to the House Senate Subcommittee on the Bipartisan Innovation Act, and she also recently was recognized as the most bipartisan freshman member of Congress. Ladies and gentlemen, please join me in welcoming the Congresswoman. Good afternoon.
Thank you. I appreciate you inviting me to join you today. And I want to thank the American Society of Mechanical Engineers for extending an invitation for me to speak about the International Space Station at this year's 2022 Policy Impact event. Thank you, Tom. I'm honored to be speaking to so many brilliant engineers and alongside policy experts who share a commitment to scientific achievement in low Earth orbit. Southern California, especially my 39th congressional district, are home to a large aerospace industry that is supported by a large ASME membership. ASME supports 37,824 K through 12 students from 184 California schools through the ASME Inspired STEM Education Program. And ASME members work for several aerospace manufacturers in and around my district that supply public missions, such as the Artemis program, as well as support a booming commercial space industry. So this event is really timely as Congress, NASA, and commercial and international partners deliberate on the future of the ISS. The ISS is a hallmark of the US's presence in space and shows what can be achieved through commercial and international partnerships. In the 20 years the ISS has been in orbit, the ISS has hosted 258 astronauts from 20 countries, including 158 American astronauts, and has supported several research fields, including water purification, drug development and disease research, physics, and horticulture, to name just a few. After 20 years of operations, the ISS is unfortunately showing its age, with cracks and leaks appearing, along with spacesuits needing replacement. As the ISS ages, NASA is in the process of transitioning LEO services to the private sector and is currently working with 3 companies to develop commercial LEO destinations, and NASA plans to act as a buyer of services. These commercial stations show immense promise and stem from the successes of the Commercial Crew Program, which closed the gap during which US astronauts rely sorely on the Russian Soyuz rocket for the transportation to the ISS. So as we build on the success of prior and current commercial partnerships, we must be conscious of several issues that must be addressed as we move forward with the ISS's transition. We must maintain American leadership in LEO. As it stands today, the United States is the unequivocal leader in space, but we cannot take this for granted. The CCP is currently building its Tiangong space station, and we have little to no information on what role the People's Liberation Army will play on the station. We must be conscious of the CCP's growing influence in LEO and its disregard for international law and what the implications of this might be for our presence in space. It is also critical that there is no gap in LEO research during the transition. In space subcommittee hearings on the ISS and Artemis programs, I expressed concern that the NASA Inspector General predicts several areas of critical research needed for the Artemis program that would be incomplete by the time the planned decommissioning of the ISS takes place in 2031, including human systems integration architecture, injury due to extravehicular activity operations, spaceflight-induced cardiovascular disease, and space radiation exposure. When I asked about this in committee, I was assured that NASA will be able to complete this critical research in partnership with its commercial partners. I'm committed to ensuring that this critical research is completed so that we can continue our deep space exploration efforts. And I know the brilliant and hardworking scientists and engineers at NASA and its commercial partners are committed to this as well. A smooth transition will also require NASA to consistently inform and update international partners on its transition plan, reach a formal agreement with them, and seek to include them in commercial LEO ventures. The ISS is an example of what can be achieved in space through international partnerships, and we should not pass on the opportunity to use multilateral scientific missions to build on existing relationships and to create new ones. Countries that we do not work with will likely have one alternative, working with China. So as we set our sights on Mars, we cannot forget the benefits that stem from America's presence in LEO, including the almost countless technological and scientific achievements that support a broad spectrum of industries and governments, multilateral cooperation in space, and research that supports our deep space exploration efforts. I want to thank you again for inviting me to speak, and I look forward to hearing from a well-qualified panel of experts about the future of the ISS. But I believe, Tom, I probably have a question for one or so.
Great, Congresswoman Jim, thank you. I just want to commend you and thank you. You've had a lot of great success in your first term in Congress, especially with legislation supporting early career researchers and the Rural STEM Education Act. I thank you for that. That to me is very important. And how do we find the next, representative? How do we find the next mechanical engineers? It's important. Your work is well appreciated.